The NEC, or National Electrical Code, requires a minimum of 6 inches of unspliced conductor at each outlet, specifically for grounding and bonding purposes. This requirement is outlined in NEC Section 300.14a. It's important to understand that this requirement is not waived for equipment grounding conductors, often referred to as ECG. The NEC Handbook, while a helpful companion document, is not a codebook itself and should not be used as the primary source for determining code compliance. The diagrams presented within the NEC Handbook are sometimes inaccurate and should not be relied upon for absolute code adherence. The actual NEC text is the only authoritative source for code requirements. When dealing with equipment grounding conductors, it's crucial to adhere to the NEC requirement of providing a minimum of 6 inches of unspliced conductor at each ECG for grounding and bonding purposes. This ensures a proper and safe electrical installation. Let's delve deeper into the NEC and its implications for grounding practices. Grounding serves as a critical safety measure in electrical systems, providing a lower impedance path for fault currents to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers or fuses. The 6-inch pigtail requirement exists to ensure that there is sufficient length for making connections and for future modifications or repairs without compromising the integrity of the grounding system. NEC Section 300.14 is quite specific. It mandates that at least 6 inches of free conductor length, measured from the point where it emerges from the raceway or cable sheath, shall be left at each outlet, junction, and switch point for splices or terminations. This applies to all conductors, including grounding conductors. The purpose of this requirement is multifaceted. Firstly, it provides sufficient conductor length for making secure and reliable connections to devices or other conductors. Secondly, it allows for future adjustments or repairs without having to replace the entire conductor run. Thirdly, it helps to prevent strain on the connections, which can lead to loose connections and potential electrical hazards. Now, let's address the role of the NEC Handbook. The NEC Handbook is a supplementary resource that provides explanations, illustrations, and examples to help clarify the intent and application of the NEC requirements. It is developed by the same organization that publishes the NEC, the National Fire Protection Association, or NFPA. However, it's crucial to understand that the handbook is not a substitute for the NEC itself. It is intended to be used as a learning tool and a guide, but the actual NEC text is the only authoritative source for code requirements. The diagrams in the NEC Handbook are often simplified representations of typical installations. They may not always depict every possible scenario or detail, and they may sometimes contain errors or omissions. Therefore, it's essential to always refer to the NEC text to ensure compliance with the specific requirements for a given situation. When it comes to grounding ECG, the NEC provides specific requirements in Article 250, Grounding and Bonding. This article covers a wide range of topics related to grounding, including the types of grounding systems, the methods for grounding equipment, and the requirements for grounding electrodes. Section 250.146, Connecting Receptacle Grounding Terminal to Box, addresses the specific requirements for grounding receptacles in boxes. It requires that the receptacle grounding terminal be connected to the box using a bonding jumper if the box is metal. The bonding jumper must be sized in accordance with Table 250.122, minimum size equipment grounding conductors for grounding raceway and equipment. In addition to the requirements in Article 250, there are also specific requirements for grounding ECG in other parts of the NEC. For example, Section 406.4c, Equipment Grounding Conductor Terminals, requires that all equipment grounding conductor terminals be identified for the purpose and be accessible. Section 408.41, Grounding of Panel Boards, requires that all panel boards be grounded to a grounding electrode system. When installing ECG, it's important to follow all of the applicable NEC requirements to ensure a safe and compliant installation. This includes providing a minimum of 6 inches of unspliced conductor length at each ECG, connecting the ECG to the box using a bonding jumper if the box is metal, and ensuring that all equipment grounding conductor terminals are properly identified and accessible. To summarize, the key takeaways are: firstly, always refer to the NEC text for code compliance. Secondly, the NEC Handbook is a helpful resource, but it is not a substitute for the NEC itself. Thirdly, provide a minimum of 6 inches of unspliced conductor length at each ECG for grounding and bonding purposes. Fourthly, follow all of the applicable NEC requirements for grounding to ensure a safe and compliant installation. Let's further explore some common misconceptions about grounding and bonding. One common misconception is that grounding and bonding are the same thing. While they are related, they are not identical. Grounding refers to connecting an electrical system or equipment to the earth, while bonding refers to connecting different metal parts of an electrical system together to create a low impedance path for fault currents. Another common misconception is that grounding is only necessary for safety. While safety is a primary concern, grounding also serves other purposes, such as reducing electrical noise and improving the performance of electronic equipment. Another misconception is that all grounding electrodes are created equal. The effectiveness of a grounding electrode depends on several factors, including the type of electrode, the soil conditions, and the depth of the electrode. The NEC specifies different types of grounding electrodes that are permitted, such as ground rods, ground plates, and metal underground water pipes. The NEC also specifies the minimum size and depth requirements for each type of electrode. It's important to select the appropriate type of grounding electrode for the specific application and to ensure that it is installed correctly to provide effective grounding. Another important aspect of grounding is the concept of impedance. Impedance is the total opposition to current flow in an alternating current circuit. It includes both resistance and reactance. A low impedance grounding path is essential for ensuring that fault currents can quickly and easily return to the source, allowing overcurrent protective devices to operate and clear the fault. The impedance of a grounding path can be affected by several factors, including the length and size of the grounding conductors, the type of connections, and the presence of any insulating materials. It's important to minimize the impedance of the grounding path to ensure effective grounding. Now let's discuss some practical tips for grounding and bonding. Firstly, always use the correct size and type of grounding conductors. The NEC specifies the minimum size of grounding conductors based on the size of the circuit conductors. It's important to use conductors that are large enough to safely carry fault currents. Secondly, make sure that all connections are clean and tight. Loose or corroded connections can increase the impedance of the grounding path and reduce its effectiveness. Use appropriate connectors and tools to ensure that all connections are properly made. Thirdly, protect grounding conductors from damage. Grounding conductors should be protected from physical damage, corrosion, and other environmental factors that could compromise their integrity. Use appropriate conduit or other protective measures to protect grounding conductors in exposed locations. Fourthly, test the grounding system regularly. The grounding system should be tested regularly to ensure that it is functioning properly. Use a ground impedance tester to measure the impedance of the grounding path and verify that it is within acceptable limits. Fifthly, document the grounding system. A detailed record of the grounding system should be maintained, including the location of grounding electrodes, the size and type of grounding conductors, and the results of any testing. This documentation can be helpful for troubleshooting and maintenance purposes. In addition to the NEC requirements, there may also be local codes or regulations that apply to grounding and bonding. It's important to check with the local electrical inspector or building department to determine if there are any additional requirements that must be followed. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. The NFPA offers training courses and other resources to help electricians and other professionals stay informed about the NEC. Understanding and following the NEC requirements for grounding and bonding is essential for ensuring a safe and reliable electrical system. By following the guidelines and recommendations outlined in the NEC, you can help to protect people and property from electrical hazards. Let's consider some specific scenarios related to grounding pigtails. Imagine an electrician is wiring a new outlet in a residential home. The electrician pulls the cable into the outlet box and notices that the equipment grounding conductor is only about 4 inches long. In this case, the electrician would need to extend the grounding conductor using a pigtail to meet the NEC requirement of 6 inches of unspliced conductor length. The electrician would use a wire connector to connect the existing grounding conductor to a new piece of grounding conductor that is at least 6 inches long. The electrician would then connect the other end of the pigtail to the grounding terminal on the outlet. Another scenario might involve an electrician is replacing a damaged outlet in a commercial building. The electrician removes the old outlet and finds that the equipment grounding conductor is corroded and brittle. In this case, the electrician would need to replace the entire grounding conductor run to ensure a reliable grounding connection. The electrician would pull a new grounding conductor from the panel board to the outlet box, ensuring that it is at least 6 inches longer than necessary. The electrician would then connect the new grounding conductor to the grounding terminal and the outlet. It's important to note that the NEC does not specify the type of wire connector that must be used for grounding pigtails. However, the connector must be listed for the purpose and be suitable for the size and type of conductors being connected. Common types of wire connectors used for grounding pigtails include twist-on wire connectors, crimp connectors, and insulated splice connectors. When selecting a wire connector, it's important to consider the environmental conditions and the potential for corrosion. In damp or corrosive environments, it's best to use connectors that are specifically designed for those conditions. Also, to reiterate the importance of not relying solely on the NEC Handbook, consider this hypothetical situation. An electrician encounters a complex wiring configuration not clearly illustrated in the handbook's diagrams. Relying solely on the handbook's simplified representation could lead to an incorrect installation. However, by consulting the actual NEC text and understanding the underlying principles of grounding and bonding, the electrician can ensure a safe and compliant installation, even in the absence of a clear diagram in the handbook. Finally, remember that grounding and bonding are not just about meeting code requirements. They are about protecting people and property from electrical hazards. By taking the time to understand the NEC requirements and following best practices for grounding and bonding, you can help to create a safer electrical environment for everyone. This detailed explanation, while not exhaustive, aims to provide a comprehensive understanding of grounding pigtails, NEC compliance, and the importance of relying on the actual NEC text for accurate guidance. Always consult with a qualified electrical professional for specific applications and to ensure compliance with all applicable codes and regulations.